Hello everyone. In this video, we are going to learn about the rest of the functions which are used for the creating the distribution plots. So in this video, we are going to learn about the joint plot function and the pair plot function. So let's begin with the joint plot function. So firstly, we will understand what are the joint plots. So joint plots are used to create a bivariate and the univariate graphs that plot two variables. It basically combines two different types of plot. And in Seaborn library, to create a joint plot, you have to utilize the function joint plot, and the syntax of this function is Seaborn dot joint plot, and in parentheses you have to pass the parameters. The first two parameters are x and y. These are the data points that define x and y axis location. The next one is hue. It is a grouping variable that will produce a components with different color. The next one is kind. It defines the kind of the plot which you want to draw. It has options such as scatter, KDE, hist, hex, rect and reside. Then we have a color. When the hue mapping is not used, only you want to specify the one color to whole plot, you have to specify the color argument. And the last one is data. It is the data set that is being used. So we will learn this function with the help of example. I will show you the examples. So here we have examples related to the joint plot function. So firstly, you can see that I call the set function as I want to change the appearance of the plot, and I pass style as a keyword argument to it, and I set its value to white grid. After that, I call the joint plot function as I visualize the data between the total and the fair data points of the Texas data set. And one of the drawback of the marker is overlapping when we have a large number of the data value. So for overcome of this drawback, I call the kind function and set its value to hex. Then I call the x label function and the y label function as I want to add labels at the x axis and the y axis. Then additionally, I pass the font size keyword argument and the color keyword argument to the both of the function and set its value to 15 and orange respectively. Then I call the show function as I want to display the plots on the user screen. Now I execute this cell and show you the output, how the plots look. So here you can see that in between we have a hexagons plotted, and on the sides we have a histogram plots. So you can say that the data points are binned into a hexagons and the distribution is displayed using the different colors. So you can see that some hexagons are of the darkest color and some are in the light color white. And here x-axis shows the total and y-axis shows the fair. So now we will move to the next example, and this time I call the joint plot function as I want to visualize the data between the total and the tip data point of the Texas data set, and additionally I pass the keyword argument to this function and set its value to scatter. Then I call the show function, and now I execute this cell and show you the output. So here you can see that x-axis shows the total, y-axis shows the tips, and on the sides we have a histogram, and inside the plot we have a scatter plot. So you can say that we have a scatter plot with two histogram at the margin of the graph. And if we look at the scatter plot, you have noticed that the columns of the total and the tip appear to the positively correlated with one another as their values rises together. So here the scatter plots move upward, and the most values are centered on the left side of the distribution while the right side is longer in the case of a histogram. So I will show you. So here you can see that in the histogram the most of the values are the center to the left side and the distribution, while the right side is a longer, and the marginal histogram are both right skewed. So now we will move to the next example, and here I call the joint plot function as I want to visualize the data between the points passengers and the toll, and this time I set the kind keyword argument to the KDE, and I call the show function. Now I execute this cell and show you the output. So here is the result. So here y-axis represent the tolls and the x-axis represent the passengers. So here you can say that the joint plot displays the bivariate density curve on the main plot. So you can say that here the main plot which shows the circles, these are the bivariate density curves, and on the margins we have the univariate density curves. Here on the margins we have these curves are called the univariate density curves. In the default cases it shows the histogram, but when we change it to the KDE it shows the curves. So now we will move to the next example. This time I call the joint plot function as I want to visualize the data between the distance and the tip. And here I set the kind value to REG and color to the gray as I want to change the color of the whole plot to one color, which is a gray, and then I call the show function. Now I execute this cell and I explain you something. You all know that the visualization represent the relationship between the dependent and one independent variable. You all know that the visual representation of a relationship between the dependent variable and one or more independent variable is provided by the regression line, or you can say that best fit line. So this reg means regression line or a best fit line, and the mathematical equation can be used to compute the regression line, and by using this equation we can forecast the dependent variable by the different values of the independent variable. And we can also spot the outliners using the regression line on the scatter plot. The outliners are the points that are the farthest from the regression line. So here you can see that here is a scatter plot and here is the regression line. You can see that the regression line, and here on the outer coverage we have a histogram, and you can see that there are the points which are the far away from this regression, like here is the point located at the above 30 on the y-axis, or this point near about the 20. These points are very far away from the best fit line, so these are points are the outliners. So I hope you clearly understand how the regression line shown by the reg keyword. So now let's see one more example. This time I call the joint plot function as I want to visualize the data between the total and the tip data point of the Texas data set, and additionally I pass the hue a keyword argument to group the color data points with different colors. And now I execute this code and I show you the output how this plot looks. So here you can see that on the sides we have a curves, and inside the plot we have a scatter plots. It is of two colors. The curves are also of two colors and the scatter plots are also of two colors. The blue marker represent the yellow taxi and the orange marker represent the red taxi. So in both cases you can see that at curves we also have a orange and the blue color, and in marker we also have orange and the blue color. X-axis represent the total and the y-axis represent the tip given by the passenger to the driver. And you can see that on the marginal plots instead of the histogram, density plots are plotted on both of the margins, showing that the data distribution of the two level of the hue variable separately. So with this we have learned about the joint plot function. Now we will learn about the pair plot function. So firstly I explain you. So with the help of a Seaborn pair plot, user can design the axis grid that share each numerical variable contained in the data over the x and y axis in the form of a columns and rows. So we can make a scatter plot to show pairwise correlation in addition to the distribution plot which shows the data distribution in the column diagonally. And the pair plot function can be used to plot a several pairwise bivariant distribution in the data set. And the diagonal plots are the univariant plots, and this displays the relationship for the n by 2 combination of the variable in the data frame of a matrix of a plot. And the syntax for the pair plot function is a Seaborn dot pair plot, and then we have to define the data set, and we can also pass the hue keyword argument, which is a grouping variable that will produce a component with a different color. So we will learn this function with the help of an example. I will show you the examples. So here we have examples related to the pair plot. I will explain you. So firstly you can see that I call the set function as I want to change the parents of the plot, and I pass a style as a keyword argument and I set its value to the white grid. Then I call the pair plot function to visualize the relationship between each pair of the data point in the Texas dataset. So I pass a data as a keyword argument and I set its value to data underscore set, which is defined as a Texas, and then I call the show function as I want to display the plot. Now I execute this cell and show you the output what I mean. So here is the output. You can see that this is the pair plot, and you can see that each variable distribution is displayed as a histogram along the diagonal boxes. So here the y-axis in first represent the passenger, and here also at x-axis it represent the passenger. So in this case it represent the histogram along the diagonal boxes, and a scatter plot is displayed for the correlation between each pairwise combination of the factor shown in each remaining box. So I explain you. So you can see that here in the first row we have a passenger, and in the next column we have a distance. Passenger and the distance are the different things, so it is represented with the scatter plot. And the next one is passenger and the fare, it is also displayed with the scatter plot, and so on. So in the next case we have a distance as a row, and in second column we have a distance in the x-axis, so it is represented with the histogram. Similarly you can see that in the toll case we have a fifth column as a toll and the fifth row as a toll, so it is represented as a histogram, and the rest of the plots are represented with the scatter plot. So I hope you clearly understand how the pair plots are plotted. So now we will move to the next example. So here I call the pairplot function to visualize the relationship between some specific data points in the Texas dataset, and these specific columns are the total and the distance. So I pass total and the distance as a list, then I call the show function as I want to display the plot. Now I execute this cell and show you the output, how the plots look. So as I told you, the row name and the column name are same, so it will represent with the histogram, and the rest of the plots are displayed with the scatter plot. So total and the total is represented with the histogram, distance and the distance is represented with the histogram, and the total and the distance is represented with the scatter plot, and the distance and the total is represented with the scatter plot. So now we will move ahead and see one more example. So here I call the pair plot function as I want to visualize the relationship between each pair of the data point in the Texas dataset, and additionally I pass the hue keyword argument to group the color data points with the different colors. Then I call the show function to display the plot. Now I execute and show you the output. So from this pair plot you have seen that each variable distribution is displayed as a curve along the diagonal boxes, and the scatter plot of the correlation between the each pairwise combination of the factor is shown in the each remaining boxes. And here you can see that we have a two color of the curves and the marker. The blue one shows the yellow taxi, and the orange one, or you can say the red one, shows the green color of the taxis. So let's see one more example. In this time I again call the pair plot function, and this time I visualize the relationship between the some specific data points, and these data points are the total and the passenger. So I pass it as a list, and here I pass additional keyword argument kind, and I set its value to the KDE as a kernel density estimator. Then I call the show function. Now I execute this plot and show you the output. So from this you can see that instead of the scatter markers it's shown as a KDE plot, and instead of the histogram it shows the curves. So in case of the total and the total it shows the curve, and in case of the total and the passenger it shows as a KDE plot. So with this we have learned about the joint plot and the pair plot function in this video, and in the next video we will learn about the rug plot function, which is used to create a distribution plot in Seaborn library.